Thank you very much. Yes, there is an Indigo Discord. It's very fun. So do we have any questions? Oh, okay. Oh, we have two microphones. Are they both on? Okay. All right.
There was a hand. There was a hand over there. I know it's Shah. He always asks good questions.
Hi, Dave. Thanks. Thanks for your talk. It was really interesting. I realized that library developers and application developers tend to be two distinct group of people.
You're gonna have to hold it a bit closer, I'm afraid.
All right. Can you hear me now?
Yes.
Okay, cool. So what I said was I appreciate that library developers and application developers tend to be two distinct group of people. So I don't actually know if you have had much of an experience writing games with your engine. But yeah, I wonder what the implications of the choices of functional programming and Elm architecture or whatever is on the game development experience. Because game development tends to be a labor of love. You tend to spend a lot of time on it, and it could be sort of overwhelming. And if you don't have the right setup, you could just get burnt out. So on a personal sort of development experience, how that sort of shapes things. But also, again, another implication, another sort of aspect of this is that could be a very big thing that you're implementing, and I'd like to know if functional programming helps with sort of splitting, shaping the way you sort of, in enterprise development, we start with interfaces and we mock things, and there's a certain way of sort of starting with POC and then developing that and changing that. And if functional programming helps that, so shapes that.
So the question is, does functional programming help with game development? There was a wonderful blog post years ago, which is where all this started, called A Worst Case for Functional Programming. And it was by a guy called James, whose surname I forgot now, I apologize to that person, who basically explained that his view, he was a game developer, and his view was that programming eliminates huge classes of error problems in terms of understanding the structure of the application, the event flow, what's impacting what, and all of that good stuff. And I was really inspired by that, and that's really where Indigo came from. I've recently written a terrible physics engine, which has made me question all my beliefs in that. But as a general concept, I think it does work. It is, especially with the Elm architecture, it is actually really quite easy to understand what the flow of your application is. So the initial use of the Elm architecture and functional programming in terms of developing games is very pleasant. Like, you can knock up a small game very quickly and you're like, oh, look, it's very pretty. It works really nicely. There's no weirdness. There's no strange state being altered or misunderstandings about when that event arrives and that kind of stuff. There is a point slightly beyond there where you try and build something bigger, and learning how to scale the application takes a bit more thought, right? But there is a pattern for that too, which I can talk about some other time. But I still believe that it's, I still think it's better. I used to be a Flash developer, and I used to make games in Flash, and this is way better than that. I mean, I'm not saying my engine can do better than Flash could do, but the experience of it for me is much better in terms of the patterns and the architecture. Is that okay? I've got a nod. Anybody else?
Cool, we have time for one more question. So,
thank you. Yeah, thank you for the talk. That's amazing. What kind of what do you produce out of the engine? Like, can you play it in a browser? Can you play it like on a cool machine? I saw Electron, so is that just compiled to JS and then ran using Electron? What's the backend?
Yeah, so at the moment, Indigo is entirely ScalaJS and runs on WebGL 2. There is, so the reason for doing that is I'm, apart from Dave there, who helps me at the back, I'm more or less on my own, apart from occasional contributors, which are much appreciated. Thank you. But what I was trying to do was limit the scope, right? I thought I can't please everybody, but if I build it in JS, I can run it basically anywhere, right? I can use Cordova for mobile, Electron for desktop, runs in a browser. You can publish Indigo games to GitHub trivially, right? And that all works really, really well. There are dastardly plans to bring Indigo to other platforms, because the kind of the notion is if we move Tyrian, which is another one of my projects, and Indigo together, Tyrian becomes the runtime, then all we have to do is replace the runtime with something that understands a different platform, and away we go, right? It's not that simple. because WebGL gives you a really good abstraction over the graphics hardware, right? So you only have to learn, okay, you've got to look out for browser weirdnesses, but but basically one thing works everywhere. As soon as you start going to different platforms, systems, using Vulkan, Metals, God knows what, there's a lot to learn for the developer as well as the engine builder, right? And that's slightly worrying to me because it might be off-putting, in fact. But at the minute, you can run it on basically anything. It's just that it's JS. Bearing in mind that this is a pixel art game engine for games that look like they were made in the 90s with some slightly fancier graphics on the side, I think that's plenty fast enough. Is that okay?
Great. Thank you very much, Dave. Big round of applause.
Right, now I'd like us to welcome Paul. He is a musician as well as a Scala developer and amazing at both. So I'm really looking forward
Around here and hide behind that while you're talking about me. All right. Hello, everyone.
Well, thank you very much. Looking forward to hearing you speak on the sounds of ScalaJs.
Awesome, thank you. So can everyone hear me through this lapel mic? Carry on, yeah. Great, all right. So, yep, very happy to be here today, chatting to you about making predominantly musical-related sounds with ScalaJs. So my name is Paul Matthews. By day, I'm a backend engineer at ClearScore, building microservices with Scala to send data to banks and other fintechs. What I'm going to do is I can hear myself coming out of my MacBook, so I'm not going to start while this is going on. It's worth me taking the time to make sure that this stops. Sorry. 1, 2. All right, we can do that. Yeah, so sorry, as I was saying, I'm a Scala developer. Working at ClearScore, send data to banks and other fintechs. That's what I do by day, but by night, I'm actually a washed up rock star. I'm continuing my fantasy by making music with Scala and ScalaJs, and then I force my colleagues, who have very kindly come here tonight, I force them to listen to my music and play with my little apps and stuff. And so yes, I'm here today doing the same to you now, but you've all come of your own volition. So I am going to elaborate a little bit more on my musical background. Obviously, publicly, calling oneself a rock star is a very, very lame thing to do. So at the least, I'm going to quickly qualify my rock stars and how that spilled over into working on music and audio with Scala. But first, what we're going to do is we're going to take a quick look at an overview of what we're going to cover with this chat today. Awesome. So the question that I'm looking to answer by the end of this talk is ScalaJS the future of web audio applications? And on the way to answering this, we're going to traverse the following topics. Are you laughing at me using the word traverse? All right. So what we're going to do is we're going to look at some ScalaJS web apps. I've got 3 of those in sort of varying degrees of quality. We're also going to look at wrapping a JavaScript library with ScalaJS, in particular the Tone.js sound and audio library. We can use a JavaScript library with Scala. And then finally what we're going to do is we're actually going to build a synthesizer from scratch using ScalaJS. Quite ambitious, but we're going to do it. So onto this musical background, and for those of you who haven't met me yet, I'm going to tell you about my background and why I have such a keen interest in musical Scala. So I basically spent the better part of 25 years as a professional musician and audio engineer, playing in bands and producing other bands before doing this almighty career pivot to become a software engineer and ultimately a Scala developer. So up here on the slide, you can see I've very modestly included some key metrics on my music career. And I also have a video top that off, which should actually summarize my music career and my life in under 60 seconds. And then we can roll on to the ScalaJS stuff. So this actually plays. I have a funny feeling there'll be no sound. Let's try turning up the volume. Let's try this. Hang on. Interesting. Oh, well, just enjoy the video, and we'll make sure that some sound happens eventually. It's not a song you would have heard before anyway. So, but anyway, the reality actually, this is actually the on-stage stuff, right? The reality is that I actually spent most of my time sitting in a van and driving a van. Well, I actually spent even more time in my studio writing and recording with different types of recording software. So as such, like digital audio and the digital audio domain, it's something I know all too well. And so I have a good starting point in understanding what we need music software to do. And so when I started learning Scala, which wasn't that long ago, I know I look like I'm head of engineering. I'm not. I started working on some audio applications because it seemed like a good way for me to get some practice and learn some more about Scala. Just some more about the key libraries, more about functional programming in general, and ultimately kind of present myself with some problems and then use what I've been learning to solve the problems. Wants to play that again without the sound. Yeah. So this talk I'm doing here today, it actually follows on from a previous talk that I've done called Sounds of Structure. I did that at ScalaDays Madrid last year. And what I did there was I covered like modeling music with algebraic data types. So it's a very music-focused talk, but I was using this sound stuff from Scala.js for that talk. So I felt like I should do another talk and explain all the audio side of it and how we're making these sounds and stuff. And in particular, how we're using this JavaScript library, Tone.js, and the web audio API for making music. So I'm not going to promote myself too much, but it is on YouTube. Awesome. So what we're going to do is we're going to have a look at a few of these web apps that I've built using Scala.js. And here comes the first challenge. And there's some audio out of my speaker. And here we go. This is one of the web apps. This is another. Let's see if this makes sound. All right. Well, thank you. Thank goodness something worked. All right. So this here was the first app that I actually spun up. And the reason I did this was I wanted something to select and play some songs for the DSL that I was working on. So it just kind of like sprung up. And then I added these piano keys purely so that I could like try out the different sounds and samples and stuff that I was using with Scala and Tone.js. Now this next app that I did, this is like a rehash of the classic 808 roll-in drum machine. And so this one here, I specifically set out to build a drum machine. So I'm going to build a drum machine. I'm going to do it in the browser. I'm going to use Scala.js. It's going to be great. And then this third one here I'll show you. We're going to use this later on. We're going to use this, to illustrate building synthesizers and how we go about that. So this one has just been built using sort of vanilla Scala.js. It's not much to look at, but it's going to be useful for us a little bit later on. Awesome. So I'm just going to go back and have a look at this first app again. And yeah, I said that the key purpose of it was for playing songs and stuff. So playing a song, it's all one thing. I had this DSL, I could describe a song. How do I play it in audio? And that's what we need a sequencer for. So what I'll do is I'll demo this sequencer. I'll play a song. This one here will be good. I didn't write this song. Still going. Because I can hear some slapback from the back room. People were clapping. I was like, oh no, they're just sitting very quietly. No worries. Yeah, so you heard the sequencer in action, right? Playing those notes. You might have heard some pretty fruity sounds as well, right? Where do those sounds come from? So I'm going to tell you two sources, all right? There's two sources, samplers and synthesizers. Put up your hands if you know what a sampler is. Not a huge amount. All right, I'll explain a sampler to you, right? So what a sampler does is it plays like audio files, right? So to play a WAV, it'll play an MP3 if you want to go lo-fi. And so I'm going to show you some samples on this thing. I'll turn this up again. That's not a sample, but this is a sample. Dum, dum, dum. You may recognize that voice, and that's me. This is all me. This is not a good idea. But I've got some nice sounds as well. Look at this. And I've got this piano. Let's see if I can play piano for you. Okay, thank you. Thank you. Yes. All right. So those are samples. Audio files being played. Sequencer tells the audio files when to be played. Now, synthesizers, right? These are no audio files. These are using like generated electronic sound. So we use these things called oscillators. We use filters and modulators to generate the sound. Now, Tone.js has a fairly good range of synthesizers, all of which I was compelled to try out. And now I'm equally compelled to show you. So here we go. First up is a monosynth. A bit louder on that. So monophonic synth, one note at a time, not that useful. Polyphonic synth, same thing, but more than one note at a time. Yeah, that's a chord. Then we've got FM synth, AM synth. If you're worried I'm going to go through the whole list, don't worry. I'll show you one more and we'll get on with it. So, okay, there we go, sorry. Okay. All right, so we have heard this range of different sounds, right, to suit like our creative contours and needs. So by the end of this talk, what we're going to do is we're going to like make our own one of those. So if you were offended by those sounds there, don't worry, because we're going to make our own one, and things should get better. Cool. Now I'm going to just swap this here. I hope that works. Amazing. So what I'm going to do now is I'm going to talk about how we can wrap a JavaScript library so we can do what we just did then. Use the JavaScript library to make some sounds. And for those of you who have never done this, actually, how many of you have wrapped a JavaScript library before with Scala? Few and far between. Roman, put your hand down. So firstly, what we're going to do is we're going to chat about why we would do such a thing. Oh yeah, I did forget to say. So in case you didn't know, ScalaJs, what it does is it actually like it's a sort of compiler library ecosystem. It compiles Scala to JavaScript. You can run it in the web browser as opposed to Java bytecode running on the JVM. Put up your hands if you already knew what ScalaJs was. Okay, there is hope. There is hope. All right, cool. So JavaScript, right? Why would you go JavaScript? Well, basically, so you can build web applications, right, and deploy stuff to the web. Web browsers potentially being the most looked at thing on the planet these days. We probably look at a browser more than we look at each other, more than we gaze out the windows. All the stuff that we used to look at, all looking at the browser. And why did I go for JavaScript? So in my case, where's Noel? There's Noel at the back there. So Noel's been trying to teach me how to write good Scala. And so he put me onto ScalaJs for my music project because I needed a sound and audio library. Scala didn't have one. And JavaScript actually offered the best option with Tone.js. So like I said, I couldn't find a Scala library. And I'm still not wanting to talk about the experience that I had with the Java Sound API. So using ScalaJs and wrapping a JavaScript library was ideal for my use case. And I speculate that it could be the same for many use cases. So because ScalaJs can interoperate with existing JavaScript libraries, tools, it can allow us to exploit a huge amount of available resources in the JavaScript ecosystem. ScalaJs integrates seamlessly with web tech, HTML, CSS, all that stuff. Allows us to build cool stuff, also known as complex interactive web applications. And I think that maybe we can look at it as less what JavaScript offers Scala and more as what Scala offers JavaScript and web development, right? So we can take all that good stuff that we love about Scala, the robust expressive syntax and strong static type system, and we can leverage this to build robust, type-safe, extendable web apps. Wow. So Scala could be the savior of JavaScript. I'm not getting emotional. Don't worry about TypeScript. But yeah. So anyway, the best bit of this robust JavaScript is going to be when you guys watch one of these apps crash. But let's cross our fingers and we'll see if that happens. So in some cases, Scala can optimize the generated JavaScript code into like highly efficient JavaScript, potentially leading to like better performance than handwritten JavaScript. And if your project here contains both server and client components, you can share this in the session, in the project. So this is all very exciting. Surely I've sold it to you. So now what I'm going to do is I'm going to get onto how straightforward it is to use a JS library in ScalaJS And so the first thing we need to do is to install the JavaScript library using npm. I feel it's kind of cute that I've used the whole slide to a terminal command there, but you do need to do that. So yeah. The next thing we need is we're going to need a bundler. So we need to add this to our plugins SBT file. So the bundler is going to play a key role in integrating our ScalaJS output with the JavaScript ecosystem, manages npm dependencies, all that stuff. Now the ScalaJS bundler that I'm using here, sorry, I'm using the ScalaJS bundler here. It was just the first one that I saw in the docs. It's not the only way to do it. But under the hood, this is using Webpack. Yeah, and then in our build SBT file, we need to enable the bundler plugin. And then in our project settings, we need to add the tone package to our npm dependencies. And that is actually all you need to do for the config. Great, so now we can use this JS library, which we do by defining something called a facade type, which is like a typed API for JavaScript libraries, similar to Typescript type definitions. So this is what this looks like. And just to break down the steps a bit, we're going to create a standard Scala object, which I've aptly named tone. This extends JS object. And then we're going to annotate this object with JS native. So this JS native annotation, it tells the compiler that the subsequent definition is a native JavaScript entity to be provided externally by JavaScript at runtime. So we're also going to use this JS import annotation here on line 2, so that we can import members from a JavaScript module. So the import name of these members is going to be inferred from what we call the objects. So what I've essentially done is I've created like a sort of parent object for the tone library, and then I've put all the libraries and classes and methods that I want to use into this object. So like my samplers, sequences, synths, audio control, all this is going to be going inside the tone object. So let's take a look at one. And here's an example of one of the imported tone classes I'm using. So this wraps the synth class. And I showed you that briefly before. It was that, well, you saw the synth class, the monophonic synthesizer. So again, we see the JS native annotation. Now the key method of interest in this synth class is this trigger attack release method, right? So it has a funny looking name, and you'd be forgiven for thinking that it performs an active aggression, but it basically triggers the start of the note and it holds it for the specified duration before releasing it. So that's what it does. It takes 4 arguments, all right? It takes note, A, B, C, that kind of thing. Duration, how long we're going to play the note for. Time, when we're going to play the note. That's what the sequence is going to use to say when the note gets played. And then velocity, how loud we're going to play the note. So let's just take a quick look at the JavaScript counterpart in the Tone.js library. So, I mean, I say JavaScript, but it's actually TypeScript. So there's actually already some type safety. Not as bad as you guys thought, right? So this is just a small section of the class, but just so you can see how we're directly utilizing this trigger attack release method and from the synth class there. So I think that pretty much covers what we need to know to wrap a JavaScript library with ScalaJS. Do you guys think you could do that? Are you going to go straight home and do it? In silence. Yeah. All right. So anyway, let's move on and have a look at how the library can be used with this Roland 808 drum machine. What I'm going to do as well, is there any chance someone can get me a beer? I can't perform without a beer. I'm just going to say, yeah, Lewis, thank you, thank you. All right, so we need to have a look at the drum machine. More negotiation with Zoom. There we go. All right. Here we go, cool. So let me tell you a little bit about the 808. And yeah, firstly, this one here was actually built using the Tyrian UI library, which as I hope all of you know, Tyrian was written by old mate Dave sitting back there, who also made the Indigo game engine. Oh, thank you so much, mate. Oh, not that one. And so, yeah, the catalyst for actually using Tyrian for this app was quite simply because I met Dave at one of these meetups last year at ITV, and I got chatting to him. I mean, this is the reason we come to these things, right? So you can meet people and, learn a bit. It's not just about the free beer. But I had heard of Tyrian beforehand. I hadn't got around to trying it out. So that's what I did. I'm going to make Dave really uncomfortable. Hopefully he's awkward. I'm just going to say, lo and behold, Tyrian's an excellent UI library. Once I got the hang of it, I could do all the things that I wanted to do. And specifically for me, I'm always thinking about how I can focus my learning. And there's a really good chance to improve my understanding of functional programming using the Elm architecture. You heard Dave talking about the Elm architecture. So I was using immutable data structures, pure functions, unilateral control flow. I mean, I got that straight off the docs. But yeah, drum machine. So this 808, right, it's a classic beloved drum machine. So this is the reason I modeled one. And when it first came out in the early 80s, it wasn't popular at all. It was a bit of a flop. But then a few years down the track, once broke musicians could buy them for cheap in secondhand stores, it actually blew up. So deep down, I'm kind of hoping the same thing happens with my music career. I mean, obviously we're not talking about me anymore. So anyway, yep. Here's what I'm going to show you the original. I've got it down here on the page. Here it is. Looks pretty cool, right? It's quite big. I mean, even back in 1980, they were already going with dark mode. So I think it's ahead of its game. We've got a single strip of buttons here for the notes. Each color is basically a beat, right? You're gonna subdivide these beats. So like 1E and a 2E and a 3E and a 4E, yeah? So going back up to mine, obviously I don't have to worry about components and costs, so I can have 4 strips. But the reason that I did this was so that I could see the pattern, right? So I can put a pattern in here. This is the kick drum line, and I can see like the strips in relation to each other, and I can see a whole beat. Because down here, right, you're gonna have to program it in and then use this knob here to switch to the next thing. So we have the luxury, obviously, with a soft version of it, of being able to have whatever like sort of components we want. But of course, you have to still be able to use it. So here's the first little beat. Let's see if this works. All right. Can anybody play the drums? We're going to have a single drummer in the house. You do play the drums. Was that the first beat you learnt? Yeah. That's rock beat 1. It's the first beat you learn. I'm going to show you a few things. Do you guys know what swing is? I'll show you what swing is. See this little fader here? See this straight beat? Like, very straight. If I put swing on it, if you're thinking, why would you use that beat? Well, basically, it's that's a genre of music that uses that swing. However, if we bring it back here and then turn it on a tiny bit, slow the beat down a bit, this sort of gentle swing, it can actually sound very good. So check this out. Can you hear how it has kind of like a laid-back feel? Yeah, well, that's what people in the music industry would say. It's got feel now, so that's what we want. I can make a bit more of a. Actually, what I'll do, I didn't plan to do this, but I'm just going to make a hard-out metal beat, because why not? And then, of course, if it's metal, we need to speed it up a little bit. Are there any hard-out metal heads in the crowd? What can I say? Creative echo. Oh, look, I've made the tempo 15. All right, let's go. There you go. There's the 808 drum machine written using Tyrion. I'm pretty happy with it. There's a lot that I need to improve on. Yeah. And thanks for bearing with me. All right, so in the case of the 808, right, those there that you're listening to, those are actually wave audio files, okay? So I'm using the sampler, and time for the sharing another screen again. Here we go. Indeed, where are those noises coming from? So unlike the real thing in the early 80s, these are wave files, okay? Back in the early 80s, you didn't have digital audio, right? So you couldn't play a wave. You'd have to have like an elaborate tape system to play like a recording. So what they did is they used oscillators and stuff, and they made something that they thought sounded like a drum, which didn't really sound like a drum. Now, what is it, 2024? Art imitates life, life imitates art. Those sounds are very popular, and I'm now using like wave audio versions of that original synthesis. So what we're doing, we're triggering the wave file using a sampler. And here's the tone.js sampler as wrapped. So we pass it this set of samples as a JavaScript object. We pass in the URL, so it knows where to get them from. Yeah, and then to play the samples, the same method again, trigger, attack, release, all the same things we've already seen. What note, how long, when, how loud. And so here, this is a look at the sampler in action, okay? So I'm taking a JSON object of samples. In this case, it's just a single sampler, right? And you can see that in that tuple there, you've got A1, right? This is the key note, right? And so that's the note that's going to trigger that kick, pull, wav, right? So that kick, pull, wav is my dub, dub, my kick drum that I made with my mouth. I'll play it again for all my fans. Here we go. Here we go, listening? See how that's lower than my dub, dub? Yeah. And that's because if you look down here in the at the bottom, you can see note and trigger, attack, release, we're passing in D1. And this is one of the great things that samplers do. If you go above your keynote, it'll pitch it up. If you go below, it'll pitch it down. So like I've used it artistically to make my, my kick drum sample a little bit lower. So it sounds more like a bass drum. Cool, so I think that from here, tone.js has got us covered. It's basically going to play the sound out of the computer. We don't need to worry about the rest. But you saw the drum machine's configurations of buttons, how I press those to define the pattern. How are we going to get from that drum machine configuration? How are we going to get from that to calling trigger, attack, release on the sampler? So you can probably envision it in your heads. You're like, okay, well, look, call that, use that sampler. But what I have is I have a music DSL, which I've previously written, which describes music with ADTs, and that's going to sit between the UI and the sampler. So this is what a full song looks like using the DSL. And this song object is ultimately the parent wrapper that contains all the information that I need to send to my audio engine, which is where the sampler instances are being managed. Now, we're really interested in the drums here, so let's just take a look at those. Cool, yep. So there's the drums there. And you can see inside that kick channel constructor, you can see I've got like kick, rest, quarter, kick. So those are individual music events, kick, rest, quarter. Those are individual music events. What I'm doing is I'm like combining them using that bar, so that pipe symbol. I've gone to using a plus. Plus is the way to do it. But at the time, I thought that the pipe symbol looked like a musical bar line, and it was more musical. However, it only actually serves its correct function at the end of every bar. So that's explaining why we've got pipes in there combining those notes. You see what we're doing? We're passing each of those drum sounds into the channels. So kick gets the kick, rest, quarter, snare gets the snare. So in the drum machine's UI, we basically need to compose what's inside the kick channel, the snare channel, and the hats channel. So we need something like that. Does that make sense? You can see we've got 16 buttons. What I've got here is I've got 16 note events, right? So because I don't want the kick on the 1, 2, 3, and 4, there's a kick on those. The rest are rests. So if we have an empty state, like it's just been loaded, nothing's been pressed, then we're going to have this. Just all rests, 16 rests here. And what I want to do is I want to combine these into that consolidated music event, that sequence. And I'm going to use this build music event method to do that. So from those keys, they've got a state. I'm taking their rest or their note. I'm then going to fold on this list of those events. And I'm going to use this monoid to combine them. And that's how we're going to have the song object. It's going to look like that. So you can see I'm calling that method build part inside the kick channel. And that's how we're going to build our UI state and take that state and then convert it into the sound output that we need. Awesome. So that's the 808 and how we got that to happen. Sounds of Scala, audio music library. So up till now, we've still been wrapping tone.js, and I like it. I've been vocal about that. I've been vocal about saying that using JavaScript libraries is a very good. If it's good for your use case, then let's do it. However, I would like to get more low level. Instead of wrapping tone.js and using those synthesizers, I might not like them as much as you do. We're going to look to build one ourselves by programming direct to the Web Audio API, and effectively start building a Scala-specific music library. So let's have a look now at how we can create a very simple synth with ScalaJS. It's not actually as difficult as it might sound, but we do have to confirm that we're on the same page with what a synthesizer is first. So here we go, black and white photo of where it all began. Look how cool that guy is. That's Robert Moog with his original Moog modular analog synthesizer. And so with these contraptions, what you do is you'd use all these cables to plug in all your different components and build your synth and create and shape your sounds. You can't really see the cables there, but you can see them a bit better there. So the thing is, what are these components that we're plugging in and connecting up here? So firstly, we need one or more oscillators, okay? So it's a device for generating pure sound waves. So for example, sine waves, sawtooth waves, something that's going to emit a constant tone, a fundamental audio signal that we can then use to combine, and we can mess with it, and we can shape and create complex sound waves. We need some filters. These are going to shape the sound more by removing certain frequencies. So we get like low pass filters, band pass filters. We need some like envelopes and modulators. You saw a little bit of an envelope with the attack release, or whatever the method's called. You saw that it's like basically amplitude, and it's over time. So like, how quickly does it start? How long does it last for? This kind of thing. That's an envelope. Now modulators, these are like a low frequency oscillator as an example. What it does is it's like, it'll create sort of variations of pitch and time, adding complexity to the sound. Maybe hard to explain, but potentially I'll show you. Amplifiers, hopefully you know what this is. Just control the volume or give us some volume at all to begin with. This is kind of like a novelty thing, like, for a hobbyist. The amplifier you're more likely to see these days is like that. But it's just not very romantic, so I went for the first one. And yeah, cool. So synthesizers, they obviously progressed to the color photo era when motorcycle companies, they got in on the act, started building synthesizers. So this here is a Yamaha CS80 analog synth. Digital synthesizers, this is what came next. With the rise of the era of the personal computer, complete with 5¼ inch floppy disks for the patches. Very cool. Who here has actually seen a 5¼ inch floppy disk? Hugo. This year. All right. Yeah. So, and this is where we're at now. Virtual synths. This is a virtual instrument. This one's very popular, massive. It sounds great. It sounds way better than anything you've heard tonight. And these we run in our computers. We patch them into our digital audio workstations. So that's the background of synthesizers. I think you've got the history. And I've shown you all these like charming and inspiring photos of great gear, but I don't want to mislead you because it's surprisingly easy to make awful and horrible sounds with them. And I am just prepping you for what's to come because at no point did I say we were going to build a synthesizer that was going to sound nice. So yeah, but let's get on to that. And after what you just saw, you know that the first thing we're going to need is going to be an oscillator. And here we have the ScalaJs facade type definition of the Web Audio API's oscillator node. So take note that the oscillator node is extending an audio node. And this is because the Web Audio API arranges its components as a graph of nodes. So I just want to say that, yeah, that comment over there, that is actually in the library code. What is he saying? I'm not sure if this is correct. He is actually correct. It works. So maybe we should make a PR for that. Because what it does is it defines whether it's a sine wave or a square wave. And we're actually using it here today. So awesome. So what I've done here is I've defined like my own oscillator ADT to try and make a simpler and more friendly API for instantiating oscillators. So you can see that this oscillator has like a given or implicit audio context object. And then on that we call create oscillator to instantiate an oscillator node. Now, the Web Audio API's audio context, it's worth mentioning because it's kind of like the highest level. It's a feature of modern web browsers. It allows us to create and manage audio processing graphs. And it acts like a container for audio sources, effects, and destination nodes, oscillators. It enables us to do things like audio mixing, processing audio data in real time. Awesome. So back to this oscillator ADT. And remember we talked about needing an amplifier. So, because we need to control the volume. So on line 3, we're creating an amplifier for doing this. Line 4, we're creating a low-pass filter. So these are other audio nodes. Line 7 and 8, we need to define the frequency. That's going to be the note. And then we need to define the type. That's the wave type. Awesome. And so here's the play method, right? And the idea is just that we can just quickly create an oscillator object and then call play, and it'll just make some noise, all right? So now you remember Robert Moog and his contraption with the cable. So this is what I want to do here inside the play method. I want to like plug in my components. So if you look at line 3, I'm going to set the oscillator's amplifier volume from whatever volume we pass in with the play method. And on line 4, we're going to plug the oscillator node into the bandpass filter, and then in turn, we're going to plug that into the amplifier. All right, so you can see how we're essentially starting to create this tree of audio nodes, but I'm visualizing it as plugging in these components in a vintage sort of analog synth. And finally, on line 5, we're going to plug this amplifier into the audio context destination, which ultimately is going to offload all this information to the browser's sound output, and you should hear something. Awesome. So on the UI, we have some buttons. This is how easy it is to make a button in vanilla ScalaJs. I won't go into too much detail about that, but you can see that we're easily instantiating a sine wave oscillator there on line 7, just calling that sine oscillator. And then on line 8, just calling play. All right, cool. So now we can have a listen to that. Now we've got to that. There we go. All right, so first up, we've got the sine wave. Awesome. Next, we've got the sawtooth. It's a bit loud, sorry. Square wave. Does it sound any different? And the triangle wave. So those are like our 4 fundamental oscillator tones that we're going to use. And what we're going to do is we're going to mix them together. So what I've done is I've instantiated all 4 of those. I've done some things. I've set the frequency of 1 to 440 hertz. The next one I've set the frequency to 220, so an octave lower. And then I've also set the other one 3 hertz below 440. So, oh goodness, I'm not going to do the math in front of everyone. 437, let's go. And basically this small amount of detune, it's inside the range of what we would consider to be in tune. What it does, it just makes the sound a little bit richer. So when you hear people singing, they're not actually singing perfectly at 440. They're all around it, really. But yeah. Cool. So what we're going to do is we're just going to have a listen to this compound synth. And I've already started with these synths set at different levels. So I'm just going to play it. You can have a listen. Oh. Cool. Doesn't sound that great. We can run this. That sounds a bit better. Right, so here's a sine wave. It's sawtooth. Square wave. Now I'm going to bring this triangle in, 3 hertz below. Sounds pretty awful, right? But if you actually put it in the context of a song, I mean, that can be an electronic act. That could be Prodigy, Chemical Brothers, Britney Spears, I don't know. So one more thing I'm going to show you is that filter. You saw I patched that in. So this is a low-pass filter. And the thing about that low-pass filter, like I said, I was an audio engineer for 20-something years. And I always hated it being called a low-pass filter because I felt it should have been called a high-cut filter because it really feels like that's what you're doing. You're cutting out all the highs when you use it. Anyway, so I'm going to show you that. Oh, cool. So you recognize that kind of sound, right? Like the DJ does that, those dance parties and all that, and there we go. I can open up again. All right, it'll do. So basically, you can see how we've mixed these oscillators together. We've changed the pitch of them to make them interact together differently. We've used some filtering on it, and ultimately what we've done is we've just built like a very simple synthesizer. All right, so that pretty much brings me to a conclusion of this talk. Let me flick back here. This is the part where I'm going to try to rope you guys into helping me build the Sounds of Scala music library. I know you're all very excited about it. I mean, Dave was also asking for people to help out with the Tyrian game engine. I don't want to like compete with Dave in any way, but I mean, we need to get this done. So there's the repo. Make sure you find it. And yeah, and so just in summary, what we talked about today, we talked about ScalaJs in the context of building web audio applications. You saw a few of those, mostly working. Then we talked about how we can wrap a JavaScript library using ScalaJs. Potentially, you can see the benefits of that. You've got like the whole JavaScript like ecosystem you can pull functionality in from, and you can use it with your own application. You don't even actually need to use. You don't even need to be like building a web audio app you use in the browser. You can have something that just that's just running locally or whatever. And then we finished up by building that ScalaJs synthesizer. And finally, I was trying to rope you guys into helping me do some work. So, oh, of course, is ScalaJs the future of web audio applications? Are you sure? Why not? Why not, I say. So yeah, cool, that's it. I'm happy, I'm prepared to take a few questions. I think I might have gone a bit over, but obviously being a rock star, I'm only going to answer the questions I like, and if I like the look of you. And also if you can keep the word count to like under 20, single sentence, atomic context questions only, please.
Any questions? I don't know whether this was working.
Hi, thanks for a great talk, by the way, and expanding my mind in terms of how Scala can be used. But first question I have is, have you plugged it into a MIDI keyboard? And if not, how could I do that?
That's a really good question, good request. Why don't you join this repo and we can work on this together. Hi, mate.
Hi. You mentioned the music DSL.
Yeah, the music DSL. I'm gonna promote myself.
Yeah.
It's Sounds of Structure on YouTube by old mate Paul Matthews.
So it's the previous talk in Madrid.
There's a previous talk where it's,
okay, cool.
I'll talk all about it. Yeah.
Thank you.
You know what? I'm actually going to talk about it again at Scala.io in February, if you're going to be there. So yeah, I'll do that again. It's quite good fun, that one. I'll like write a song on the fly using the DSL. Yeah. So thank you. Kilter, please ask me something nice.
Both the talks have talked a little bit about the Elm-like architecture for doing graphics. I just wondered if there was any scope for a sound functional architecture and what that would be.
Yeah, I mean, I think I mentioned to you the reason that I used Tyrian was like, obviously, like I'm trying to learn all the time, and I think, yeah, like functional programming, it's not something where I just went like, I mean, Noel said it to me, because yeah, make your functions pure, handle your effects. It's one thing to say it. Yeah, it's another thing to do it, you know what I mean? So it takes a bit of practice like everything. So I'm like, I haven't been successful in just making everything like pure and handling all my side effects and stuff, especially not like when I've like hacked together UIs and stuff. Like that first one, it's like side effects all over the show, that first UI. The Tyrian one, well, because Dave's like set it up and he's used the Elm architecture, and it perpetuates my understanding of like using like a functional process. So I'm really interested in making the Sounds of Scala library functional. I mean, I'm not just saying that to get you guys involved. I think it's I think it'll be fun. That's a target anyway. I mean, there are some challenges in like audio playing in sequence and stuff. There's some quite big challenges there, but I mean, you're only going to learn by looking to take on the challenges and finding a solution to the problem. So thanks for the question. It's really good.
All right. Well, thank you very much, Paul.
Awesome. Thank you very much.